Hello, welcome to Math 251 Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video, we will take a quick overview of section 1.4, inverses. In this section, we will define the idea of an inverse function. And the definition here just says that we're going to switch the domain and the range. And so switching the domain and the range means your x and y will switch, and your domain is going to be your range is going to be your domain, etc. And so there's going to be some interesting playing with these things and some interesting graphical repercussions that's involved with dealing with inverses. We're going to define the idea of one-to-one. So one-to-one function says that, well, a function itself, to start with, says that for each input you get a unique output. One-to-one says that for each output you're going to get a unique input. So if your output, if your function or if your value in the range is unique, then that has to have come from a unique input. So in this particular drawing example, our first graph here, f of x is equal to x squared, is not one-to-one, because you pick a value in the y-axis that's positive, then there's two possible ways to get there, and so that is not unique. On the other hand, x cubed is one-to-one, because regardless of what y value you pick, you're always going to only be hitting that with a unique x value. And so this brings us to the horizontal line test to test whether a function is one-to-one. So if you draw a horizontal line and your horizontal line is going to pass through no more than one point on the graph, then you have a function that's one-to-one. Once we've established that a function is one-to-one, we can safely find its inverse. And so graphically, it turns out that the inverse is going to be reflected about the line y is equal to x. But if you notice the reflection around y is equal to x, you notice that the x and the y are still switched. And so if you have a BA if you have an AB in your original graph, you're going to have the point BA in your inverse graph. Okay. So what if a graph is not one-to-one? Can we still find the inverse? Well, our first example of a function that's not one-to-one is y is equal to x squared. Yet we know that there's an inverse to that, and that's the square root of x. Well, it turns out that you can only do this inverse for non-one-to-one functions. You can only find the inverse if you restrict its domain. So if you notice in the first graph here, we restricted the domain to just the positive values. And if we restrict the domain to just the positive values, then you can find the inverse, which is a square root of x. What is not more commonly seen is our second graph, where you restrict the domain of y is equal to x squared to just the negative side of that. And if you do that, then its inverse is going to be the negative square root of x. So notice that both of these functions and their graphs are reflected about the y equals x line. And so this is going to be important for us to be able to restrict domains of functions that are not one-to-one, because we're going to need to find some of these values. So aside from y is equal to x squared, another really popular set of functions that need to be restricted are the trig functions. We know that the trig functions are periodic, they go on forever, and if you draw a vertical or horizontal line, it's not going to pass the one-to-one horizontal line test. So for the sine function, for example, we would need to restrict the domain to just between negative pi over 2 to pi over 2. And then so you can safely, once you've restricted the domain, you can safely do the reflection and get your sine inverse function. Similarly with a cosine inverse and the rest of the trig functions as well. So this is our quick overview of inverses, and that's it. Good luck.